Today we are going to start lesson 11.6, adding and subtracting rational expressions. The first part of today is we are going to find the sum or difference of these rational expressions, and we have to state the excluded values. Now, in all the examples that we're going to do today, what you'll notice is just like fractions, when we add, we have to have a common denominator. Once we have a common denominator, it works just like a fraction. You add your numerators together, which gives me 9, and you keep the denominator the same, 2x. We have monomials, so when we do monomials, we need to have our excluded value of x cannot equal 0. Again, that's only a monomial in which the denominator contains a variable. All right, number 2. Number 2, again, notice we have a common denominator. So when we've solved this, our denominator is going to stay the same, y plus 4. All right, now we're going to subtract our numerators, and again, like terms. So 3y minus y is 2y, and no constant minus negative 8 is positive 8. Don't forget to distribute that negative right there. All right, now what we want to do is we want to see if this can simplify. In our first example, it couldn't simplify. 9 over 2, they have no common factors. But when you kind of look at these numbers here, you kind of see the 4 and the 8 kind of are related a little bit. So what we're going to do is we're going to factor them. Remember, with binomials or trinomials or any polynomial, you have to factor to simplify. So I'm just going to double check that. And 2 is my GCF on the top, so this is 2 times y plus 4. And on the bottom, I can't factor that at all. That's prime, so that's y plus 4. And my hunch was right, that they have a common factor of the binomial y plus 4, so we actually can simplify that. And our final answer here is 2. All right, our excluded value, going back to our original problem, to make this 0, y can't be negative 4, so y cannot equal negative 4. And for this one, it's exactly the same because, again, we already had common denominators, so this is our answer. All right, number 3, again, common denominator. So when we add our fractions, that's going to be our denominator. And we're going to do our numerator. So we have x minus, no x is over here, so that'll just be x. 3 minus 1 is positive 2. Again, just like the last one, I'm kind of curious here to see if something will simplify. The 2's are kind of talking to me a little bit. So let's factor the top and bottom and see if we have a common factor. X plus 2 is prime, so that will be just x plus 2. And I'm going to put that in parentheses because remember, we can only cross off binomials with binomials. And I'm going to do product sum down here at the bottom. And to get that, it's going to be x plus 2 and x minus 1. And my hunch was right. We do have simplifying able to happen. We're going to cross off that x plus 2 on the numerator and denominator. So our final answer here is going to be 1 over x minus 1. And again, I need to do my excluded values. It's kind of hard to see what your excluded values are here, so that's, again, another reason why we should factor to try to find them. So I'm going to go down to my factored form. So for this first one here, it can't be negative 2. And for my second one here, it can't be positive 1. And that's the answer. All right, now unfortunately, not all of our rational expressions are going to have common denominators. So just like when we have fractions that don't have common denominators, we're going to have to find one. So the second part of our lesson today is I'm going to teach you how to find the least common denominator of two rational numbers. And how you do it is you write the factorization of each denominator and use the greatest power I'm going to underline that for you, of each factor that appears in the denominator. It's easier to show you it than to tell you verbally. So let's go right into number 1. All right, number 1 is an example of a monomial denominator. Those are the easiest ones to find an LCD for. What you're going to do, I'm going to write LCD equals. Okay, this only works for a monomial. Is you're going to look at the two numbers, the coefficients 7 and 4, and figure out what the common denominator would be for 7 and 4. And the common denominator is 28. Then you're going to look at the variable parts. And as they have a common variable, you're going to pick the one with the largest exponent. So this has an exponent of 1, and this has an exponent of 3. The largest one is 3. So my LCD is 28g to the third. Again, monomials are going to be that easy when finding the LCD. Now, number 5, we have a pair of binomials, and they're not the same. So that's a little bit more complicated. Here's what you do. To find the LCD, you are going to factor both of the denominators completely. So the first one is t squared minus 4, and that's a difference of 2 squares, so that factors into t plus 2, t minus 2. And then our second one is t minus 2. And that can't be factored at all. There's no GCF. It's not a difference of 2 squares. So it's prime, so it'll stay the same as t minus 2. All right, to find the LCD, what you're going to do is you're first going to look for anything that they have in common. So they both have the t minus 2. So that one is going to be the first part of our LCD, what they have in common. I'm going to cross them off to signify that I used them. And then anything else that's not in common, that also has to be a part of the LCD. So I'm also going to include the t plus 2. So it turns out in this problem that the LCD matches what the first fraction had. Okay? Let's try another one. All right, so again, we're going to find just the LCD. Notice they do not match. So we're going to factor them completely. So the first one is x squared minus x minus 6. And that's product sum. And it's going to be x minus 3 times x plus 2. Second one is x squared minus 3x. That's a 3. And they have a GCF, so pull that out. And then I'm left with x minus 3. And that can't be factored any further, so those are my two completely factored. Again, to find the LCD, what you do is you first look for things that are in common between both of them. And they both have this x minus 3. That's the first part of the LCD. And then everything else that's left over after you cross off common pairs is the rest of the LCD. So x plus 2 will be part of the LCD. And a singular x, or a monomial of x, will be part of the LCD. Now I like to write it to have my singular monomial term first. So I'm going to do x parenthesis, x minus 3, and x plus 2. And again, that's my LCD. Why don't you go ahead and pause the video and try to do number 7. I realized after I got you to try to do that on your own that I got a little overzealous, so you may need an eraser handy depending upon what you wrote. So hopefully you factored them both out and you got 6 times x minus 5 and 9 times x minus 5. So when we go to do our LCD, we do have a common binomial, so I am going to use that. Now we have this 6 and this 9. Now hopefully you didn't write both 6 and 9 because they actually have a much smaller common denominator. Again, we're going to go back to what we did with number 4, is when you have these monomials, you want the lowest common denominator of those monomials. So the common denominator of 9 and 6 is 18. So the LCD is actually 18 parenthesis x minus 5. If you wrote 54, go ahead and erase that and write 18. All right, that's all that you're going to do for today. Tomorrow, Mrs. Moyer is going to teach you how to add and subtract rational expressions after you find the common denominator. So stay tuned for that. Have a great day, everybody.